Hello and welcome to this new session on cryptography and network security. Already we have seen the physical cipher, non-physical cipher, mathematics introduction to cryptography and network security. And on the earlier last class we have talked about DES, and this class we will be continuing it with AES. AES stands for Advanced Encryption Standard. AES basically started after the DES when the DES started falling off over there. So AES was introduced, and AES was also introduced by NIST, National Institute of Standard and Technology, in December 2001. AES is a symmetric key block cipher published by NIST. What was the criteria why we required it? Just because of the three reasons where DES falls short. The three reasons are security, cost, and implementation. When we talk about in February 2001, when NIST announced the draft of the Federal Information Processing Standard, the FIPS, was available for public review and comment, finally AES was published as FIPS 97 in the Federal Register in December 2001. So basically, in the same what we had in DES, there used to be a we used to insert one data of some X bit of data, 64-bit of data, and it used to get processed over there inside it. But when we developed it, we got to know that every time we will not get 64-bit of data. If I have a lesser amount of bit of data, I need a in a, some cryptographic algorithm to involve it into a better way. If I have a large chunk of data, then it should be done in a different process. We cannot just imagine that if I was up to have only 64-bit of data, and every time it has to go for 16 rounds. So when AES was done, AES was made for 10, 12, and 14 rounds, respective of 128, 192, and 256 bits of data. That depends. If I have 198 bit of data, then I will go for 10 rounds, and 192 bit of data 12 rounds, and 256 bits of data for 14 rounds. So AES is a non-physical cipher that encrypts and decrypts a data logs of 128 bits. Okay, so when we do it, the number of rounds depends upon the chunk of data that I have. It similarly has the same thing, that 128-bit plain text will be given into the circle where the pre-round transformation will be done, and then rounds will be counted with an information to round n. Round n basically means the number of data that I've inserted, as per that that thing will be taken care of, how many rounds it will be taken. Then I will get a ciphertext. Similarly, in DES, we have here different key element over here with a key generation over there. There we have add round key generation over here. Here we have key expansion over here. Key expansion also odds of 128, 182 or 256 bits of data only. Again the same thing, 128 bit, then 10 rounds to 192, 12 rounds to 56, 14 rounds. So basically, when we are talking about it, let's talk about the introduction part of it, so that in our upcoming diagram we can easily understand what it is. When we talk about a byte of data is there, that will be converted like a byte of data is there. That chunk of data would be divided as like a matrix, either in a straight row matrix or a column matrix. Already we have seen in the mathematics of cryptography how a row matrix and a column matrix look like. Then if I have a word, same way, the word would be either kept in a row format or a column format. So if I have a complete block of data like this, it will be formed in this way, where 0, 0, 0, 1, 0, 2, 0, 3 will be formed out of it, or in a word format if in a one way. So this how the basically the data units are converted, or the block of data is converted into a matrix format. Because this AES is completely based on matrix format, and all the things will be that four formations that we are talking about, we'll be talking about, that was all about this matrix thing. So this is the type of block of data where it will be showing. It can be shown in this way, where B0 comes over here, then B1, B2, B3, like this, and then next chunk in the next column. It will be formed in this way, either of them. It will block to state and state to block transformation, which has been shown here. So basically, when I am talking about one round of AES, it looks like something like this, where one state is there. The state is the plain text of data that we have, which will be first done into a sub bytes. The bytes will be substituted over there. Then the state would be given to shift rows. The shift rows will shift the rows and the columns of the data that we have over there. Next comes the mix column. This columns will be mixed over here. So first we have shifted the rows, then we mix the columns, and then we add a round key to it. Then we get the state of first round. So similarly, each and every round would be taken care we have. So if like in DES, as we've seen that there were 16 rounds where we used the mixer and the swapper after that. Till round 15, 16th round, either we used no swapper or two swappers over there. Here, what we use in each of them, we will use sub bytes, shift rows, mix columns, and add round key. Every time this thing would be used, and the add round key is the place where the key would be functioned or XORed with the data that we have. So when we talk about it, the four functions that we talked about was substitution, permutation, mixing, and add key adding. What happens in substitution? It's something like DES where we used to substitute the bytes and all. The first transformation, the sub bytes, is used for encryption sites to substitute a byte. We interpret the byte as two hexadecimal digits. The sub bytes operation involves 16 independent byte to byte transformation to it. So whatever the data of sub bytes I have, that will be shifted over there. If I have a byte of data which is at AB16, that will be sub byted to CD16. Either of the places as per the algorithm's interest or requirement, because it is all dependent upon the algorithm, because it has to again refix it over there. So it's all done as per the algorithm, from which column from which place the data would be taken, at what place it would be kept off over there. So this how we have it, and this is the complete process how we can see it, where we have a state of data over there. This state of data comes to this process byte or sub byting or process, where it can be repeated for 16 times. Then what happens as it goes for it, the data gets inversed over there and then byte to matrix. That byte of data that we have is converted into a matrix format, and there is an X element which has been generated by the algorithm only, and that algorithm data will try to multiply this thing and minus with this C2 C7, that element that we have, that is the ciphertext that we get out of it. This ciphertext will be again kept over there, compared with the D and Y, and the matrix to byte data is kept over there. And this matrix to byte data is transferred to the state over there as a ciphertext over there. So this is what we call subbyting process. Next comes the permutation. When we talk about permutation, it is also known as the shift rows over here. P box we used in DS, substitution box or S box we used in DS, but here the same process has a different name over here. When we talk about shift rows, it is basically when we transform the rows of the matrix from one place to another. If like is shown as an example, like if I have to shift for one row, this row will be going to the last, and the last one will go to the second last, and then it will go to the first position, second position, and the second position goes to the first position. This how the rows are shifted over there as per the known of the algorithm, how much he wants to shift the rows and all. So this how it will look like this, and then the inverse of it will rectify it to the formation of the basic first state or the plain text format. When we are talking about the mixing part, this mixing comes into picture where we can actually see it that X element is multiplied and summed with B, and this how it goes on, and we get a state out of it. There we have a constant matrix over here which is given by the algorithm only, and the old matrix is the format that we get it from the earlier version. Once we get it, we multiply and we get the new matrix format. This new matrix format is used for the multiplication purpose. When we are using a mixed column function, we can see the state has been given over there and multiplied with a constant matrix element to get a mixed column division over there. Once we get the mixed column, we keep it into the same column place, and the columns get mixed up over there. Last and the fourth round that comes is the key adding or add round key. Here what we do, we take a key, sum it or XOR with the one row of column of matrix from the state, and we get a add round key format over here. You can see it over here, and this thing comes back to the normal state again. So see how this happens. It happens to the key expansion. To create round keys for each round, AES uses a key expansion process. If the number of round is NR, the key expansion routine creates NR plus one of the 128-bit round key from one single 128-bit cipher key. So that is what we do in key expansion. If we have a block of data like this, it takes one set out of it. It uses as a word number 0 or the first element of the word, and then it XORs with the T element that it has. This T element exhausts with it and we get a W4 or the word number 4. So every time it does it and it gets a 1 out of it. So every time that word that I get, word if I get is could send as a rot word, and this rot word would be used for the substitution word, and which has been XORed with the archon over there to get a TI. This TI will be helping us to figure out how many rounds this I will help figure us to find out how many rounds we will be using, and we will be putting in the for key inspection key expansion. So this T would be again used for the key part over there to expand it to the key for the add round key. Cypher's AES uses 4 types of transformations for encryption and decryption. In the standard, the encryption algorithm is referred to as the cipher and the decryption algorithm as the inverse cipher. So this is the original design of the cipher or the AES that we have, where we have a cipher key which is coming up from word 0 to word 3 for figured out and added to the add round key for the plain text, and which goes to the first round. In the first round, it is a sub bytes, shift rows, mixed columns, and add round key again. And this how it goes till the point. Here it has been shown for the round 10 rounds over here for a minimum example, and you can just see it. And this how it goes on continuously. So this how it an AES complete process goes on. So changing key expansion algorithm. Instead of using inverse round key transformation in the reverse cipher, the key expansion algorithm can be changed to create a different set of round keys for the inverse cipher. For to do the analysis of AES, the 3 major reasons why we required an AES was security, implementation, simplicity, and the cost of it. So let's start with the security. AES was designed after DES. Most of the known attacks on DES were already tested on AES when it was initially came into the market and for the revision and all. So first it was used with the brute force attack, which we already see in DES what happens, and AES is definitely more secure than the DES due to the larger key size that it has. Statistical attacks, numerous tests have failed to do statistical analysis on the cipher text. Differential and linear attacks, there are no differential and linear attacks on AES as yet. Starting with the implementation, AES can be implemented in software, hardware, and firmware. The implementation can use table lookup process or routines that use a well-defined algebraic structure. Along with it, the simplicity and cost, the algorithm uses in AES are so simple that they can be easily implemented using cheap processor and a minimum amount of memory. So these are the 3 major reasons why we had it, and this was all about AES. I hope everyone was able to understand about AES. If you have any question or any doubt on AES, do please comment on it, and do post messages over there so that it helps me to understand about your regular questions and answers, so that my upcoming videos will be more better and enhanced to develop on those question things, and I will be able to solve your answers once you post in all your questions and queries that you have. Till then, we meet on the next lesson. Bye.